Okay, so for this question here, given that y is x squared minus 2ax minus 2 over x minus 2a, where a is a constant, for what values of x is y increasing? So I believe this question is troubling quite a lot of you, so I'm going to be here to help to explain it to you today. All right, so first, we know that if we are talking about y to be increasing, it means that we are considering that we need our f prime x, okay, or our dy dx to be less than 0, okay. So from here, what do we do next is that when we look at, we have to first find the different derivative lah. So let's differentiate, and if we do a differentiation, dy dx, apparently I have to use quotient rule lah. Okay, so if I differentiate the top first, that will give me 2x minus 2a multiplied by the bottom, which is x minus a, right? And then after that, so this is my du dx, this is my v, minus dv dx. So differentiating x minus a, that will give us just 1. Differentiating x is 1, differentiating a will be just 0. Okay, so from here, this will just be a 1, and keeping the what I have, the top, that will be x squared minus 2ax minus 2 x minus a. Alright, so from here, after that, do the simplifying yourself. I believe what you will get is, I'm not going to go through the manipulation part. I think those you are comfortable with it. Now, this will give you eventually x squared minus 2ax plus 2a squared plus 2 over x minus a bracket square. Now, over here, from this part to this part, you're just doing nothing but using the quotient rule of differentiation and simplifying your numerator by bringing the terms together. Okay, so from here, what do you do next is you then you consider that if you need this dy dx to be positive, right? Consider that if this is my dy dx and I need this to be positive, we basically need the entire fraction to be more than 0. Now, if you look at the denominator by on its own is already non-negative, right? Because this is already a squared function. Okay, as long as x is not equals to a, then this is already guaranteed to be positive, right? So then if I look at the numerator, now if I want this entire fraction to be more than 0, if my denominator is positive, that means that I also need my numerator to be positive as well. Okay, so how do I make my numerator positive? Okay, so from here, what I do is now I look at this function. All right, consider this, consider the numerator. If you need x squared minus 2ax plus 2a squared plus 2 to be positive, all right, what we do is we think a bit about the graph of this. Consider this graph. Okay, so if we need this graph, right, that also means that, you know, if I were to consider y equals to x squared minus 2ax plus 2a squared plus 2, right? If it is positive, it also tells you that this graph has to be above the x-axis. It will tell you that this graph is above the x-axis. Okay, so it means that this graph is above the x-axis. So what does that tell you? If you want this function expression to be positive, it means that you want the graph to be above the x-axis. Okay, what else? Now think about GH3 math. For a graph like this to be always positive or above the x-axis, this means that you likely are thinking about discriminant. So we are considering that we need the discriminant to be less than 0. Okay, now simply look at this expression here. You can see that if you want to form the discriminant, which is b squared minus 4ac, right, we need this discriminant to be less than 0 in order to guarantee that your graph is always positive. All right, positive means two things. Number one, discriminant less than 0. Number two, coefficient of x squared has to be positive, which in this case is already given. Okay, it's already given. Okay, so from here, what do you do next is now you then see that, okay, just simplify this on your own. I'm not going to do it for you. You should be able to get negative 4a squared plus 2. And you can see that this is always less than 0. This is less than 0 for all values of a. Alright, for all a. So now if you know that your numerator, right, is going to be more than 0. Now if you look at your numerator, now back to the numerator, this is always more than 0 for all values of a, right? And if you look at the denominator, as long as x is not equals to a, okay, if x is equals to a worse, it's not even going to be defined. So you can see that as long as x is not a, your denominator will be positive, your numerator is also going to be positive. Okay, it means that basically the answer, right, as long as x is not equals to a, okay, it's not equals to a, then y will be increasing. Okay, so basically the range of values is just x more than a or x less than a. Okay, thank you.